Quantity discount model. When you buy in larger quantity, you know that suppliers are willing to give you some break. When you buy in larger quantity, obviously you have to decide how much you are going to buy. It will increase your holding cost, but it will cut down your purchase price. So it's a balance between those two. Let's look at this example. Let's assume that you're buying an item for which the annual demand is $5,000. Holding cost is expressed as 20% of your purchase price, and your ordering cost is $49 in this example. And the price breaks are given in the table below. If you buy between 0 and $9.99, you get no discount and you pay $5 per unit of the item you are purchasing. But between $1,000 and $2,000, if your lot size is, you get 4% discount, and selling price or purchase price in that case is $4.80 for the entire lot. If you buy anything over $2,000, your discount is 5% and your purchase price becomes $4.75. All right, so how do you handle this kind of situation? You have to figure out optimum quantity for each price break and go from there to figure out what should be the optimum quantity. I'll explain these 4 steps with an example. So let's continue working with this example. Right, so calculate Q for each price break. All right, so for $5, notice the holding cost is 0.2 times 5, which is $1. So in this case, if you calculate the lot size, economic order quantity, that turns out to be 700 cars per order, which is okay. If you're buying 700 cars, you will pay $5. So that's fine. For next price, which is $4.80, if you calculate your EOQ, that turns out to be 714 units. And you know that if you buy 714 units, you will not get $4.80 as your price. Let's do the same calculation for next price break, which is $4.75, and if you do the calculation, it's $7.18, which is again not feasible because to avail this price of $4.75, you must buy at least 2,000. So optimum lot size for $4.80 is not 714, but you have to buy at least 1,000. And similarly, you must buy at least 2,000 to avail the price of $4.75. So your EOQ quantities become 700, 1,000, and 2,000 respectively. Next, you need to figure out the total cost. But before that, let me explain what's going on here. So you notice for the first price, discount 1, the optimum quantity is 700, which is the blue color curve, and that falls within the price range. For the second one, the red color curve, you will notice that EOQ is 714, but 714 is not feasible because you will not get that price discount. To avail that price discount, you must order between 1,000 and 2,000. And on that side of the curve, you will notice the least cost occurs when you order 1,000 quantity. And that's why we selected 1,000 as our economic order quantity when you have to pay $4.80. For the third discount, you must buy at least 2,000. Okay, because below that you will not get a discount. All right, so what we have done here is put all these values in a table. So discount number 1, price per unit is $5. You're buying 700 quantity at a time. Your EOQ is 700. Your annual purchase cost and product cost is going to be $25,000. If you move across horizontally, you will notice your annual ordering cost, your annual holding cost, and total cost. And I've done the same thing for number 2 and number 3. If you look at the total cost, you will notice the least cost occurs for number 2, which is 24,725. And therefore, your economic order quantity should really be 1,000. And that concludes our discussion on this topic. Please review this video as many times as you need to understand this discount model. And don't forget to look at the assignments. Thanks.